Hello everybody, meteorologist Jacob Campbell here with your WeatherNow forecast for Thursday and Friday. So before I get into it, I want to say this forecast is going to be a little less detailed than the previous ones. I've got a climatology exam tomorrow, which I'm studying hard for, and then I also have a quiz in one of my other classes, little general education class, that I have to study for as well. So let's get into it. So we've got a vast warm-up compared to Sunday, Monday, and Tuesday. Really, it was kind of chilly for a lot of the country on those 3 days, and so now we finally see a significant warm-up. So we've got 60s throughout the upper Great Plains and even into some of the Rocky Mountain states, and then in the lower Great Plains, we've got temperatures in the 70s, and then some areas of Texas in the 80s. Although I want to point out too that there were certain areas that showed 90s in Texas. However, I'm not exactly sure that you'll see 90s tomorrow. This is Thursday. But there were some areas in this little core of 80-degree temperatures that were showing 90s. Then throughout southern Arizona, New Mexico, and California, you could also see temperatures here in the 80s. Then there's this area here of temperatures in the 70s that just stretches generally through majority of the South. So from North Carolina all the way over to Central California. And then above that, we've got temperatures in the 60s, really in that little border range between the 70s and the 50s. And it's just a little thin area out here near the east, and then we're moving off to, it really thins out here around the Missouri, Arkansas area. Then we get into the middle of the country, and it just really broadens out here. And so a lot of the areas in here will see temperatures really well into the 60s. And then it kind of stretches down, and this is just how the upper air patterns are laid out. So we've got air rushing in from the south up here and then throughout these areas, and then air rushing in from the north in these cooler areas in the 50s and the 40s, as well as little areas up here in the 30s and little bits in the 20s. But fortunately, we're seeing most of those areas leave the country, which is really great news. Now for Friday, you're going to love what you see because almost all of the blue is completely gone off the map. So we've got areas in New York and Pennsylvania that are showing the 30s. This may be an anomaly, but it did show up on both the European models and the GFS models, so it looks to be about accurate, as well as a little bit in Maine here in the 30s still. But the majority of the New England area, you guys are going to be in the 40s. In the middle of the country, we got 60s throughout Ohio, Indiana, Michigan, Illinois, and then to the north west from there. And then we've got all of these areas of 70s, ranging from Virginia, parts of North Carolina and South Carolina, all the way east and some north through Kentucky, Missouri, all the way into the central Great Plains here, and then just shooting down past the Rocky Mountains, which are going to be in the 50s, which is actually pretty warm for you guys. And then down to the southwest here. And this whole swath, really about half the country, is going to see temperatures in the 70s. So very, very spring-like. Spring has finally come. And you may notice that it jumps directly from 50s and 60s in the Rocky Mountains to 70s and 80s. And that's just because the area of buffer, the 60s and 70s, was almost too small to show up on the maps. And so really, it's just as soon as you descend from those mountaintops, it's going to be in the 70s. So you got 50s up in the mountains and then 70s immediately at the bases. Then there are these areas of temperatures in the 60s, which take up actually another significant portion of the country, as well as temperatures in the 50s for a lot of the northern states, which is still pretty good. We also do have this little buffer zone right here between the 40s and the 60s. In the Ohio, Pennsylvania, West Virginia, North Carolina area. But overall, very warm. And so I also wanted to say that I've gotten some comments, and then I also got some comments on David Schlotthauer's videos, that the European model is running a few degrees too cold. So I have gone through and manually tried to make up those little cold areas. The areas that I saw that deserved warmer temperatures based on what the upper air was doing, I gave them a little boost in the temperatures that they were getting. So that's pretty much that. Moving on to the severe storm risk for Thursday. So we've got this little area in Louisiana, Mississippi, and Missouri, then a little sliver of Texas that are in the slight risk for severe storms area. Your highest risk is going to be large hail. Then you've got a smaller chance of damaging winds, and then you've got an equal chance of damaging winds and tornadoes. So essentially what's going on is there's enough cape and there's enough wind shear, and I'll explain why the wind shear is there here in a minute, in this area, that you could have a couple of isolated supercells and then a couple of isolated tornadoes, but this is by no means an outbreak or anything like that. We're just predicting that there will be a couple of these really strong supercells and a couple of tornadoes coming about, maybe 2 or 3 tornadoes or whatnot in that area. But it doesn't look to be like it's too big of a chance, so you guys are going to be okay on that whole tornado front. Then we've got this marginal risk for severe storms in the areas surrounding through Alabama, Tennessee, Missouri, Oklahoma, little sliver there of Kansas, and then parts of Texas as well. Once again, hail is the primary concern. The Cape values are a little lower for those surrounding areas, and the wind shear isn't necessarily there for you guys. So you guys are going to have a smaller chance of severe weather, but because all that Cape is there, you still have that chance for hail. It's just a smaller chance in this little bullseye area right here. Then in those surrounding areas around that, from Georgia and Florida up to Indiana and then over to Kansas and then down through Texas, you guys are in just a risk for thunderstorms. Nothing too severe, nothing really to write home about. You just have a little bit of a disturbance in the upper atmosphere that's going to help aid in thunderstorm development. So you guys may have a couple of thunderstorms. Now, I mentioned something in the previous video about this little shortwave here, and some of you were saying that you didn't know what a shortwave was and stuff like that, and that's bad on me. I should have explained it a little bit. So basically, this is a 500 millibar map, and so you've got the different heights at which the 500 millibar level is located at, and so you've got 550 here, you've got 560 here, and these are all in meters, and then you've got, it looks like 576 there, 570 here. And so essentially what's going on is this is upper level flow. So this is about halfway through the troposphere, which is the section of the atmosphere that we live in. And in these areas, this is really where you're going to get your weather from. So if you live north of this flow right here, so if you live in this area up here, you guys are going to get warmer temperatures than people that are on the south end of the flow, because temperatures are being brought from warmer areas up north, and then they cool off when they get up north, and then they move to more southern areas, which brings the cool air from up here down to the bottom. And that's kind of how these flows work. So when you get little short waves, or sometimes they're called disturbances, if you watch like local news, they'll often call these like upper air disturbances or something like that. What happens is you get these northern flows that come down south, and then they kind of bottleneck right in this area here. And so you've got this pooling of cold air in the upper atmosphere, and then the daytime heating is warming up the lower atmosphere, which causes convection, because the warm air wants to be on top of the cold air. And so they will gradually switch places, and then this outflow out here is just, it's all of that warm air that's now moving northward, or up as opposed to down, is moving out of the system again. So then you get that northerly flow, so from south to north, when you're on the opposite end of a shortwave here. But the other thing that a shortwave does, not only does it allow for pooling of cold air aloft, it also, so you see these little lines here, those are lines of 500 millibars essentially. And so if the 500 millibar point is lower, that's a low pressure. If it's higher, that's a high pressure. So when you get these areas here that are really scrunched up, so these heights are very close to each other essentially, you get that wind accelerates through this area here because wind likes to travel from high pressure to low pressure. So if you're making it so that these they're not really isobars, but they're close to isobars. If you make it that these isobars are really close together, air will flow very quickly between the higher pressure to the lower pressure. It just means that you've got a strong low pressure. And so you get acceleration of winds in those areas. So winds in this area here in Louisiana and Mississippi is around 60 knots. And then around it, they're at about 40 knots. But every time you see those lines thin out, like over here to the west, just off of California, you get accelerated winds. And so those accelerated winds aid in wind shear, and they also aid in severe storm development. And so if you've got these areas in here of high shear and high cape, you've got a severe storm event. However, this is a very weak shortwave. So shortwaves like this don't often cause severe storms just because they don't have enough, it's not a low enough pressure essentially. And so if you had a very strong low pressure, you would often see these shortwaves dip way down. And then that's when these winds in between the isobars here would accelerate to 100 knots, 125 knots. And when you get that, you get a higher risk of severe storms in those areas. But there's not really very much shear in here, so the main threat is that cape, the convection that this little shortwave is bringing, and that'll just provide with some large hail. So you're not really looking at a high wind event or a high tornado event, mainly just a high hail event. But then you also notice these areas where that wind is accelerated, and you may be wondering why there aren't severe storms in those areas. And the main reason for that is just because there's not cape to sustain it. So you need both convection and wind shear in order to produce severe thunderstorms. And so if you have the wind shear but you don't have the cape, you're just going to get a windy day. You're not going to get a day with severe weather. Or if you have the cape but you don't have the wind shear, you may get some really heavy rain and maybe even some hail, but you aren't going to get any high winds or tornadoes and whatnot. So that's just kind of how the atmosphere works, and I wanted to kind of give that to you guys so that we were all on the same page with the terminology that I'm throwing out. But yeah, that's pretty much how it is. So I hope you all enjoyed this forecast. I will get you a severe storm threat for Friday tomorrow after my exam's over. So once again, I hope you all enjoyed, and I hope that you're having a wonderful Wednesday, and I will see you all tomorrow. Thank you. Have a good one.